In the last video, we talked about arithmetic operators as well as some C++ concepts like constant variables, global and local scope variables, increment and decrement, and some other useful concepts, so make sure to check out this lesson later. Today we will discuss relational operators and logical operators. In C++, we have 6 relational operators and they are in front of you right here. Let us start with the first one, which is the equality operator. Let's go down to the main function and declare two integer variables called num1 and num2. Let us assign the value of 12 to num1 and assign the value of 13 to num2. Now let me go ahead and declare another variable of type boolean, and I will call it is equal, and I will say something like num1 is equal to num2. Now what is happening right now? Well, basically what I'm doing here is I'm using the equality operator, which is represented by double equal signs, and I am comparing if num1 is equal to num2. So num1 is 12, right? And num2 is 13. Are they equal? Well, of course not. 12 is not equal to 13. This is why this relational operator, this equality operator, will return either true or false. So because 12 is not equal to 13, of course it will return false. Always remember that relational operators will take two operands, one on the left and one on the right, and the expression will either evaluate true or false. Well, of course, based on what you're doing. So here we are comparing if num1 is equal to num2, and because they're not equal, this expression will return false. And it is reasonable for us to actually store the output of this expression inside a variable that stores a boolean, or a variable of data type called bool. So that is why I created a variable of type boolean, and I'm storing this expression inside it. Now let's go ahead and see out this expression, and let me go ahead and write a simple message like num1 equal to num2, and what I'm going to do here is I'm going to say bool alpha and give space right here and say is equal. So is equal, and I did something wrong right here. I should say this and give the space right here like this. And if you don't know what bool alpha means, I'll explain it right now. So we know that if you see out a boolean value like true or false in the console, you will not get the word true or false. You will get either 1 for true and 0 for false. What bool alpha does is that it will give you the word by itself. So if you got true, instead of printing 1 on the console, you will get the value true. And same goes for false. You will see it right now. So let me go ahead and open the terminal. Let me clear it. So I'll say something like g++-o file.exe file.cpp. This is a new way of running your program, and we saw this in the last video. So I'll say something like file.exe. Let's see what we got. 12 equal to 13. Well, we got false. And indeed 12 is not equal to 13. Now let's go to the other relational operator called the difference operator. So instead of saying is equal, I'll say is not equal, for example, and num1 is not or different than num2. So what I'm doing here is I'm comparing for difference. I am checking if num1 is different than num2. And is num1 different than num2? Well, yes, it is. So what will happen here is that this expression will evaluate true, and the value of true will be stored inside this variable. Okay, let me go ahead and fix the message right here, and let me go ahead and fix the variable right here. So is not equal. Let me go ahead, compile, and run my code. As you can see, we are asking that if 12 is different than 13. Well, yes, it is. So that is why we got the value of true. So right now, let's go ahead and try the less than operator. So let me change the variable name. I'll call it less than. Okay. And now what I'm going to do is I'm going to check if num1 is less than num2. How to do this? Well, it's pretty simple. This is the sign that represents the less than operator. So what I'm doing here is I'm checking if this operand, num1, is less than this operand, which is num2. Okay, so is num1 less than num2? Well, let's see. Num1 is 12 and num2 13. Is 12 less than 13? Well, yes, it is. So that is why this expression will evaluate true, and the value of true will be stored inside this variable. Let's go ahead and print the value on the console. So instead of is not equal, let me go ahead and write less than. Now let's compile and see the output. Oh, I forgot to compile. compile, then launch the exe file. Okay, so is 12 less than 13? Well, yes it is, so that is why we got true for this expression. We also have less than or equal. Let's go ahead and see what this is. So less than or equal is this operator. Let me go down here and fix the variable and fix the message as well. So what this does is it checks if num1 is less than num2 or is equal to num2. So let's say right here, let's say num1 is 14. Well, basically 14 is not less than or equal to num2. So we should get a value of false. Let's go ahead and see. Yep, we got false. But what if num1 was also 13? And as you can see, we got true, because the less than or equal operator will give you true if the first operand is either less than the second operand or equal to the second operand. So this is the less than or equal operator. Now let's go ahead and check out the greater than operator. So greater than, and let me go right here and say, this is the greater than operator. Let me go ahead and fix the message right here, and let me copy this and paste it right there. Okay, so the greater than operator takes, of course, two operands, just like the other relational operators, and it tests if num1 or the first operand is greater than the second operand. So num1 is 12 and num2 is 13, so is 12 bigger than 13? Well, of course not. This is why this expression will evaluate false. Let us see that. So compile and run. As you can see, it gives us false because 12 is definitely not greater than 13. So now let's go ahead and check out the greater than or equal to operator. So this is the greater than or equal to operator. Let me fix the variable. So greater than or equal. Let me go ahead, copy this and paste it right here, as well as let me go ahead and fix the message. And let me change the value of num1 to, let's say, 14. So look at this. We are asking if num1 is greater than or equal to num2. Num1 is 14 and num2 is 13. Is 14 greater than or equal to 13? Well, yes it is. So this expression will evaluate true. Now, if num1 is also 13, will we get true? Well, yes, of course we will get true because num1 is equal to num2. And let's go ahead and try it out. So, no, let me compile first and then launch. As you can see, we got true. And if I go ahead and put it as 14, of course we will still get true because 14 is greater than 13. Let us go ahead and see it. As you can see, we got true. And so these are the relational operators. You can use also other data types to compare or to use with these relational operators. So I could say something like declare this variable and say 2.3 equal to 2.4. So I am using two doubles to compare. Like I'm comparing if 2.3 is equal to 2.4. What do you think we will get? We will definitely get false. So if I go ahead and display the expression, so I'll say first of all bool alpha and then expression. Let me go ahead, run this code, and let's see what we will get. We will get a false, definitely. Now, of course, you could use other operators like the less than sign, less than or equal to sign, and you get the idea. Of course, you could also use strings. Let us say we want to compare two names. Let's say we have Dave, and I want to compare if this name is equal to this name. Well, it is not equal to this name because this D is in lowercase while this D is in uppercase. Let us make sure, or let us see the output. Excuse me, I need to compile first, then launch, and as you can see, we got false because those two strings are definitely not equal. Now we will go ahead and explain logical operators. We have three logical operators. We have the AND, we have the OR, and we have the NOT operator. Let's go ahead and start with the AND operator. Let me go ahead and create a expression variable that stores a Boolean data type. Let me go ahead and say this: num1 equal to num2. We saw this earlier. But let me go ahead and say and num1 greater than 10. So what am I doing here exactly? First of all, this is the AND operator, the logical operator called AND. But as you can see, there's only one ampersand right here. Instead, in the comment right here, I said we can have two ampersands. And of course, they are different than each other. And we will explain the difference. But first of all, any logical operator will take multiple expressions. So as you can see here, we have this expression on the left and we have this expression on the right. So first of all, we are checking if num1 is equal to num2, and we are checking if num1 is greater than 10. So we have two conditions to check. So is num1 equal to num2? Well, this is false, as well as is num1 greater than 10? This is true. So we have false and we have true. What we will get? As an output, we will get false. I will show you the truth table of the AND operator, and you will see that the AND operator will give us true only if both of these conditions evaluate true. This is it. So, but why did I only use 1 ampersand? So let's say we got here false. So num1 equal to num2, yes, we will get false because 12 is different than 14. Now with 1 ampersand, it will tell C++ or it won't tell C++ to stop right here. It will leave C++ to go ahead and continue. So we know that with AND, we should have both expressions to evaluate true in order to get true for all of the expression. While we got here false. So there is no need to continue to check if this one will evaluate either true or false. This is why we use double ampersand. So when you get false right here, it will stop and it won't continue to check what this expression will evaluate. Now why this version of the AND operator is better? That's because it's better for the performance of the program. So I know this is a small program and performance is not a big deal, but let's say you had a big program, and so this is extra work for C++. So if you got here false, there is no need to go ahead and check if this one will get either true or false, because either way you will get false as an output. I hope that makes sense. Let's go ahead and see out the value. So I'll say bool alpha right here, and I'll say expression. Let me write expression correctly. So expression. Let me go ahead, run the code, and let's see what we will get. As you can see, we got false because num1 equal to num2. This will give us false, and so we will stop right here because we know that with the AND operator we should get both of those expressions should evaluate true in order to get true. Let's see it. So if num2 was also equal to num1, this time we should get the value of true. And look at this, we got true. That's because both of those expressions evaluated true. Now with the OR operator, you can represent it with one straight pipe. And yes, there's a difference with one straight pipe and with double straight pipes. So with the OR operator, it is enough to have only one expression to evaluate true for the whole expression to evaluate true. So if the expression on the right evaluates true, we will get true for the whole expression. But if both expressions are false, then we will get false. Now, let us go ahead and explain why we have double straight pipes instead of one pipe or one straight pipe. So basically, just like with the AND, in the OR, if this expression evaluates true, there is no need to go ahead and check for this one and see if it evaluates true or false, because either way we will get true for the whole expression, because we know that with the OR operator we only need to have just one expression to evaluate true in order for the whole expression to give us true. That is why we use the double straight pipe. This tells C++ that if you get here from this expression true, then there is no need to continue to check this expression. This is it. Well, but if you get false for this expression, then C++ will definitely go ahead and check if this expression will either give us true or false. Now in our case, is num1 equal to num2? Well, yes, it is. It will get true, or num1 greater than 10. Well, both of those expression gives us true, so definitely we will get as an output the value of true. Now let us see. If I go ahead and say instead of the equals operator, equality operator, I will say the difference operator. So I am checking if num1 is different than num2. Well, definitely num1 is not different than num2, so this expression right here will evaluate false. But we won't stop here. We should go ahead and evaluate this expression. Now, is num1 greater than 10? Well, num1 is 12, so 12 is greater than 10. And so yes, this expression evaluates true. And because we are using the OR operator, the whole expression will evaluate true. Because remember, we only need to have just one expression to evaluate true in order to get true. But what if I had the AND operator? Do you think we will get true? Well, let us see. Now let me go ahead, clear this. No, let me go ahead and just compile first, then run. As you can see, we got false. Why? Because we are first of all checking if num1 is different than num2. Well, this evaluated false, so definitely the whole expression will evaluate false. Now this is the OR operator, and let us go ahead and check out the NOT operator. So the NOT operator is represented with an exclamation operator, or exclamation point. As you can see, there it is. Now what it does is that it flips true to false and false to true. So remember that this expression gave us earlier the value of false, right here. Now with the NOT operator, it will give us true, because it will flip false to true. So let's go ahead and let me compile first of all, and run this. As you can see, we got true. This expression will give us false, but because we use the NOT operator, it will flip false to true, and so that's why we got the value of true. Let's go ahead and use something else. Let's say OR right here. Let me say something like equal. So num1 equal to num2. Are they equal? Yes, they are. So this whole expression will evaluate true. But with the NOT operator, this will give us false, because it will reverse the true to false, or flip true to false. Let us see that. So as you can see, we got false, because it flips true to false or false to true. Now I have a small challenge for you. Can you guess the output of this phrase or this expression? And yes, you can. You are seeing that we can stack all of those logical operators together in a single line. So how about you go ahead and pause this video and guess the output of this expression, and don't copy this code and paste it in your IDE and discover the output. How about you just go ahead and try to discover the output by yourself. So make sure to do this and comment below your answers. Now thank you for watching this lesson. Make sure to check out the previous lesson by checking out my C++ playlist for all my C++ tutorial videos. Make sure to subscribe and stay up to date to this C++ tutorial series. Now I invite you to watch one of these end screens that will appear right now, and I hope to see you in the next video.